We think extinction is sudden, a cataclysmic flash, a final deafening roar. But the history of life on Earth tells a different story. More often than not, extinction isn't a sudden event. It's a slow leak, a gradual unraveling, a series of small, seemingly disconnected failures that accumulate over time, weakening a species' resilience until it can no longer withstand the next shock. It's a process that begins quietly, in the background of our busy lives, often masked by the noise of our daily concerns. We are conditioned to react to immediate, visible threats. The fire in front of us, the storm on the horizon. But the most profound dangers are often the ones that build incrementally, below the threshold of our collective attention. We often ignore that leak until it's already too late. The warnings are there, whispered in scientific papers, presented in quiet conferences, and logged in databases. But they don't scream for our attention. They are the slow, steady tick of a clock that we've learned to tune out. This is the great paradox of existential risk. The most catastrophic possibilities are often the least immediate, and our brains are wired to prioritize the immediate. We are standing in a room where the foundations are slowly eroding, but we are too busy arguing about the color of the curtains to notice. In labs and universities around the world, scientists map dozens of ways humans could vanish. They are the cartographers of our potential doom, working to understand the terrain of our future. These are not abstract thought experiments. They are rigorous, evidence-based assessments of plausible threats. From the cosmic to the microscopic, from natural cataclysms to self-inflicted wounds, these scenarios form a chilling catalog of our vulnerabilities. Let's explore 7 of these real, researched pathways to oblivion, not to inspire fear, but to foster understanding and, ultimately, action. First, the classic threat from the cosmos. Asteroid strikes. We know this story. 66 million years ago, a rock the size of a mountain struck the Yucatan Peninsula, ending the reign of the dinosaurs. The immediate devastation from such an impact would be immense, but the secondary effects are what pose a truly global threat. A large impact would eject trillions of tons of dust and soot into the atmosphere, shrouding the planet in darkness for years. This impact winter would cause global temperatures to plummet, leading to the collapse of agriculture and the starvation of billions. While a dinosaur killer event is exceedingly rare, occurring on a timescale of millions of years, smaller but still civilization-altering impacts are statistically more likely. The good news? This is one of the most preventable existential risks. Through projects like NASA's DART mission, we have proven that we can alter the course of an asteroid. The key is detection. We need a comprehensive global network of telescopes scanning the skies, giving us the decades of warning necessary to deploy deflection technologies. It's a planetary defense system we can build if we choose to fund it. Second, a threat from beneath our feet: supervolcanoes. Unlike a typical volcano, a super-eruption is a planet-altering event. The eruption of the Toba supervolcano in Indonesia 74,000 years ago was so massive it may have pushed early humanity to the brink of extinction. An eruption on this scale today from a caldera like Yellowstone would be catastrophic. It would blanket entire continents in thick ash, destroying crops, contaminating water supplies, and grinding modern infrastructure to a halt. The release of sulfur dioxide into the stratosphere would create a volcanic winter, reflecting sunlight and dramatically cooling the planet for a decade or more, triggering a global food crisis. While the probability of a super eruption in any given century is low, estimated at around 1 in 10,000, the consequences are so severe that it demands our attention. Unlike asteroids, we can't prevent an eruption. Our defense lies in monitoring, modeling, and resilience. By improving our geological monitoring systems, we can get better warning signs. And by developing plans for global food security and resilient infrastructure, we can mitigate the worst of the fallout. Third, a threat we've all recently become intimately familiar with: runaway pandemics. The COVID-19 pandemic was a stark reminder of our vulnerability to novel pathogens. It was a dress rehearsal, and it revealed deep flaws in our global preparedness. A future pandemic could be far worse. Imagine a virus with the transmissibility of measles, the mortality rate of Ebola, and a long asymptomatic incubation period. Such a pathogen, whether emerging naturally from a zoonotic spillover or engineered in a lab, could spread across our hyper-connected world before we even realize the danger. The 1918 flu pandemic infected a third of the world's population and killed tens of millions at a time of limited global travel. Today, a similar pathogen could circle the globe in days. Preventing this requires a multi-layered defense, robust global surveillance to detect outbreaks early, investment in rapid vaccine and therapeutic platforms, and stronger public health infrastructure in every country. It means treating global health not as a matter of charity, but as a matter of shared security. This leads to our fourth threat, a darker side of human ingenuity: engineered catastrophe. As biotechnology, nanotechnology, and artificial intelligence become more powerful and accessible, they open the door to unprecedented risks. A deliberately engineered superpathogen designed to be maximally destructive is a terrifying possibility. But malice isn't the only danger. An accident in a high-containment lab, a misaligned artificial superintelligence pursuing a poorly specified goal, or a self-replicating nanotechnology that runs amok could all lead to global disaster. These are black swan events, unforeseeable and with extreme consequences. The challenge is that the very research that promises to cure disease and solve our greatest problems also creates these new vulnerabilities. Managing this risk requires a new kind of global governance. It means establishing stringent, verifiable international safety standards for dual-use research, fostering a culture of responsibility within the scientific community, and having open conversations about which technological paths are too dangerous to pursue. We must ensure our wisdom keeps pace with our capabilities. Fifth, the crisis already underway: climate collapse. This isn't a future risk, it's a present reality. But its full existential potential is still unfolding. We tend to think of climate change in terms of degrees of warming, but the real danger lies in tipping points, thresholds beyond which the climate system shifts into a new, much more hostile state. The collapse of the Amazon rainforest, the shutdown of ocean currents like the AMOC, or the release of massive amounts of methane from thawing permafrost could trigger runaway feedback loops that are impossible to reverse. This wouldn't just mean more heat waves and stronger storms. It would mean the collapse of global food systems, mass displacement of populations from uninhabitable regions, and constant escalating conflict over dwindling resources like water and arable land. It's a slow-motion collapse of the ecological foundations of civilization itself. The solution is clear, though politically difficult: a rapid global transition away from fossil fuels, coupled with massive investment in carbon removal and adaptation. The clock is ticking louder on this threat than any other. Sixth, the risks that hide in plain sight: slow systemic failures. Most risks don't look dramatic at first. They are the quiet degradation of our essential systems. Consider the global food supply. It relies on a handful of staple crops, pollinator insects that are in steep decline, and stable weather patterns that are now destabilizing. A convergence of factors, a new crop blight, a continued collapse of bee populations, and a multi-breadbasket failure due to drought could trigger a food crisis of unprecedented scale. Or consider our ecosystems. The slow tipping points, like the acidification of our oceans or the loss of biodiversity, are eroding the planetary life support systems we depend on for clean air, fresh water, and a stable climate. These aren't single events, but a death by 1,000 cuts. They are the ultimate slow leak. Addressing them requires a shift in perspective, from focusing on isolated problems to understanding the interconnectedness of our world. It means valuing resilience, diversity, and ecological health, as fundamental components of our global security. Finally, the seventh threat, which underpins all others: governance and policy failure. We could have perfect technical solutions to every one of these risks, but they are useless without the political will and international cooperation to implement them. A lab safety lapse becomes a catastrophe because of weak oversight. An ignored early warning about a pandemic becomes a global crisis because of a lack of coordinated response. The slow march of climate change continues because of political gridlock and the prioritization of short-term economic interests over long-term survival. This is the meta-risk. Our inability to cooperate, to trust science, to plan for the long term, and to act decisively in the face of clear and present danger is perhaps our single greatest vulnerability. When institutions fail, when misinformation paralyzes action, and when nations retreat into rivalry instead of collaboration, the window to solve any of these other problems begins to close. Strengthening our capacity for wise collective action is the bedrock of our survival. The terrifying truth? We have the power to reduce many of these threats. This isn't a story of inevitable doom, it's a story of choice. For every risk, there are people working on solutions. For every danger, there is a pathway to safety. We can build the telescopes, fund the research, strengthen the institutions, and change our policies. The knowledge exists, the technology is within reach. What's missing is a sufficient sense of urgency and the collective will to act. We possess an unprecedented ability to foresee our own potential ruin. The question is whether we will use that foresight. We can steer our future through research, cooperation, and smart policy. These are not just buzzwords. They are the tools of our salvation. Research illuminates the risks and reveals the solutions. Cooperation allows us to tackle problems that no single nation can solve alone. And smart policy translates that knowledge and cooperation into concrete action, building guardrails against the worst possibilities. It means investing in prevention instead of only paying for disaster relief. Shock grabs attention, but prevention saves us. A headline about a catastrophe is a record of our failure to act. A scientific paper that prevents that catastrophe will never make the news, but it is infinitely more valuable. So what can you do? It starts with a simple, powerful act. Stay curious. Read beyond the headlines. Understand the science. Learn about the work being done by organizations dedicated to reducing existential risk. Then, demand accountability. Ask your leaders what they are doing to address these long-term threats. Vote for policies that prioritize resilience, scientific research, and international cooperation. Your voice, joined with millions of others, can shift political priorities. And finally, support the science that keeps us off that countdown clock. The future of humanity may not be decided in a single dramatic moment, but in the quiet, persistent work of thousands of scientists, policymakers, and citizens who choose to look beyond the immediate horizon. They are patching the slow leaks. They are reinforcing the foundations. Our survival depends on their success, and their success depends on our support. The clock is ticking, but it is not a countdown to zero. It is a call to action.